As we have finished the discussion on thermodynamics first law part, now we are moving towards the thermodynamics second law part. The topics here we will discuss here: entropy, its meaning and different things, and second law statements. Now the first term, the new term we have to discuss here, that is entropy. This is a new term which has not been discussed in case of first law of thermodynamics. Now what is the meaning of entropy? Entropy is what is the meaning? First of all, what is the meaning of entropy? We have to remember that it is the measurement of disorderness of the system. Secondly, it is the measurement of chaos of the system, particles actually. Measurement of randomness of the system. So entropy means that disorderness, chaos or randomness of the system particles. So depending on that, entropy can be defined. Now we have to remember that as the chaos or disorderness, that means entropy is directly proportional, we can say, with the disorderness. That means as it is increased, entropy also increase. As it is decreased, entropy also decrease. So we have to remember that. That means disorderness, entropy and disorderness is directly related with each other. If it is increased, entropy increase means disorderness increases. If entropy is decreased, that means disorderness decreases. Now, so it is a very important part. We have to remember that. Now moving towards the property. What are the properties of the entropy? Property, as I discussed earlier in case of enthalpy or internal energy, like that. Like enthalpy or internal energy, it is also path dependent function. That means path function. Sorry, it is not path independent function. Path independent function. That means it is state function. Like the internal energy, in case of internal energy and enthalpy also we have discussed that it is state function. Now, so this is the thing, that means state function means it depends only on initial state and final state. It does not depend on the path. Now next the important thing, that means the property, it is the most important property. Next the important thing, what is the unit of entropy? Entropy is represented by S, and entropy is represented by S, and it is mathematically it can be represented as, that means ds, that means change of entropy, dq reversible by T. dq means, we know q means the amount of heat absorbed in reversible process by T in the absolute temperature. T temperature in absolute scale. Absolute scale means Kelvin scale. Now, so what will be the unit in that case? Let's see. Very simple way we can find out the unit of entropy. So because it is the dq by t, so what will be the unit? unit will be like that. That means calorie, temperature is there per Kelvin, calorie per Kelvin. So it can be represented as entropy unit, in short form EU. That means entropy unit, it is an entropy unit. Or in case of SI unit, it is joule per Kelvin. It is SI unit, so joule per Kelvin. So these are the unit of entropy now, or entropy change we can say. Now you have to remember that if it is mentioned for 1 mole, what will be the unit? For 1 mole, what will be the unit? For 1 mole, the unit will be joule per Kelvin per mole. So this is the unit of entropy. Now the physical significance. What are the physical significance of entropy? First of all, we have to remember that entropy increases. Entropy order, most of the time it will be gas is the maximum one, greater than liquid phase, greater than solid phase. I think it is very easy to understand, because in case of gas system, gas particles attraction force is very less, their movement is maximum. That means maximum chaos is there, so maximum disorderness is there. So this is, in this state the entropy is the maximum. Whereas in case of solid state, the particles are well arranged, their attraction force is maximum, so movement is minimum. That's why least disorderness is there. So here the entropy is value is also least for any system gaseous state having the highest entropy, whereas in case of solid the lowest entropy will be there. Now for reversible process, entropy change equal to 0. For reversible process, the entropy change is equal to 0. We have to remember that. For any spontaneous process, obviously that is irreversible process, entropy change is equal to positive. That means entropy will increase. For any spontaneous process, we have to remember that for any spontaneous process, irreversible spontaneous means irreversible process will be there. The natural process we can say also, for any natural process or spontaneous process, irreversible process, entropy change will be positive. Now in case of equilibrium state, at equilibrium state, entropy is maximum. We have to remember that. So these are the very important part. We have to remember that in terms of entropy. Now these are physical significance I have told. Now the practical effect. Now practical experience in case of entropy. Now if this question is given, practical effect we are going to discuss over here. In case of practical effect, if say ice is melting, ice to water, if this question is asked, first practical process, so ice to water, so here if the entropy is S1 here, Si and here Sw, so where the entropy is more, obviously Sw entropy is greater than Si. Why? I think very easy to understand. As I mentioned earlier just now, that means in case of solid state the entropy is the minimum comparing to the lower comparing to the liquid part. So this is the liquid part where movement of the particle is the maximum, whereas so not maximum, comparing to this it is more. But if we compare with water and vapor, again same thing, if we consider it is Sb and it is Sw, in that case Sb greater than Sw. So overall Sb greater than Sw greater than Si. So always, not only for in this case water, for any case this will happen. Now for any reaction, say this reaction I am selecting over here, calcium carbonate is heated over here, heat is given, what will be the result? Calcium oxide will be there, that is solid, plus CO2 gas is prepared. So these are the preparation. So if this question is asked how the entropy changes happen, whether it is positive or negative, our answer will be obviously delta S will be positive over here, because initially 1 mole was there, now it is 1 and 1, that is 2 mole is present over here. So obviously number of mole has been increases, that means number of particle has been increases. As the number of particle is increases, obviously randomness or chaosness or disorderness also increases, so obviously entropy also increases. So it's the thing we have to remember that. Now if this question is asked, on the other hand, if this such type of question is given, say H2 plus O2, formation of H2O. If we do the balance over here, so obviously this will be the balance equation. Now if this question, how the entropy change is happening over here, so obviously initially number of mole 2 plus 1, that is 2 plus 1, that is 3 here, and here 2. So obviously number of mole is decreasing, obviously chaosness or disorderness also decreasing. Here delta S change will be negative, so here entropy change is decreasing. So few cases we have discussed. So if we think in terms of entropy, in every case we can easily find out whether entropy is increasing or decreasing depending on the number of particles or depending on the number of moles, whether it is increasing or decreasing. Depending on that we can easily find out whether how the entropy change is happening over here. So after that we have finished it up. After entropy is finished, we have finished up the entropy part. Now moving to towards the next part, that is the second law of thermodynamics. What is the requirement of second law of thermodynamics? First of all, we have to remember that in case of first law of thermodynamics, we cannot find out the change of direction. Where the direction, that means whenever action is going on, in which direction the action will go on. So in case of that means in which direction the reaction or action will go on, and in case of second law, actually it tells us how the action will whether the action will be spontaneous or non-spontaneous. Now different statements over there, I have written all the statements over here. Statements, that means first statement I have that means Clausius statement. We can say, without external heat, machine cannot convey heat from lower to higher temperature. So So it cannot be possible to create such kind of machine which can transfer heat from lower temperature to higher temperature without any external heat. Now Lord Kelvin's statement, it in a cyclic process heat convert into work along with transfer of heat from higher to lower temperature of body. That means in cyclic process heat convert into along with the transfer of heat from, that means in here heat can be converted into work, but along with the heat should be transferred from higher temperature to lower temperature in a cyclic process. For isolated spontaneous process, entropy change delta S is positive. Just we have discussed. That means in case of isolated spontaneous process, entropy change is positive. No machine can convert heat into equivalent amount of work done in a cycle. There cannot be such machine cannot be created that 100% conversion of heat into work done. It cannot be possible. Some wastage of work heat will be there, must be there rather. And the last one, the entropy of the universe tends to maximum. It's very important, we have to remember that the entropy of universe tends to maximum. So these are the very important statements for second law of thermodynamics, and we have to remember these statements. And so we have discussed about entropy as well as second law of thermodynamics.